Welcome back. So we ended last time with creating a sell order on IMX for this aspect juggler card. I mean, obviously it's still going to be up. Not really a fair price, 1.34 ETH. So of course that didn't change. So this is probably going to be a bit of a shorter stream, but I did want to implement a few more methods from the library today. Now I did already write a little bit of documentation for each of the methods, so that has been added, but I didn't change anything else. So didn't feel that it was really necessary to cover that. But as you can see there, it's a bit long. The file is a bit longer now, so that's just because there's some documentation added to each function. Now the first thing that we can probably do, now that we've created an order, is to see if we can actually cancel that order as well. So the way we do that, let's make a function cancel order, which takes an order ID and an Ethereum private key. As its arguments. Okay. So let's see how what the function looks like in the actual library. I'll just copy paste it into the into Visual Studio. Just a sec. So yeah, takes an order ID, private string, private key string, and a buffer. Now the buffer once again is just a return whatever the server returns. So we'll just create a string buffer of 1,000 characters so that we're sure that it can store the result. The order ID is going to be a number or a string, so we'll do the same thing we did. Oh, that's another thing I changed. This, of course, doesn't need to be a hex string, so I removed hex from the NFT ID in the sell NFT function. Let's see. Order ID. There we go. And then just return. Okay. Now, so how do we actually get the order ID from an order? Well, if you remember it, when we created an order, we actually see the order ID in the result. But obviously we don't want to just store order IDs for no reason, so we're just going to look it up using the API. Let me just get the API reference. Now, of course, we could go through the API reference and look up exactly how to do this. That would, well, we're probably going to do that sort of thing later when we actually make more of a trading application. Right now, we're just writing wrappers for the functions we have in our library. So for now, what we can do is just use the inspect element and take a look at how exactly does the official marketplace actually get that number. And then we can just get it in the same way. So you just go to network, click here. Let's see. So it's probably by the orders. Yeah, oh no, that's the wrong one. It's this one, because that one's already filled. So that's probably a previous order for the same card, I'm guessing. I haven't checked, but that's what I would guess. Anything else interesting here? Tokens, yeah, so this, no, that's not really that interesting to look at. Hang on, let me close a few tabs here. We open this. Yeah, so this is the from the assets endpoint. It's getting the actual card. I think the order ID is also in here. Yeah, so it's here. And it's also, we can also get it using the orders endpoint. That should get us the same ID, 244942. Where is it? 244 and ends with 942. Yeah, so this is the order ID. So we'll just comment this out for now. Actually, we'll place it underneath here. And we'll do IMX cancel order ID and Ethereum key. And let's print this so we can see the result. Let me just, let's run this. But it didn't print anything. What did we do? Did we not return it correctly? Oh, because we didn't give it a, we didn't pass the buffer. Let me check if it did actually cancel, if it did cancel. Yeah, so it did already cancel the order actually. If we switch back to the browser, it's no longer there. But we'll just create a new order again. And then cancel it. There we go. All right. So that should bring back the order. As you can see, it's here again. Now, actually, if we refresh this, we should get a different order ID. So 244755386. And that should also be the order ID that we see here. Oh. Yeah. So that's the same order ID we got. So let's just copy this. Let's see if I can set this up this way. I show you the desktop. So right now it is on sale. And once I open this, it goes away. Yeah, so it once again prints the order ID, but without a status when it is cancelled. So the next function we'll do is transferring. Let me get the function for that real quick. So again, takes the address, ID, receiver address, key, and then the buffer, of course, for the result. And we can do some copy pasting from our sell function. We don't need the token ID, of course, because we're not selling. Just doing a transfer. So key, address, ID. We can do the same thing for receiver address, though that is most likely already going to be a string, but you never know. Oh. There we go. Let's see. Oh. And let's return the result again. Okay. I think I'm going to put you in wait for a little bit again. So I'll just look up a wallet that I can transfer it to, and then we'll do the and then I'll be right back when I'm actually going to do the transfer. Okay, so I have a wallet address that we can transfer to. So we'll just do receiver. Actually, we don't need the, this doesn't really need to be a string. It could be, but it's converted into a string either way. And we're of course going to use the same address and ID that we used previously because it's still the same card. So what we're going to do here is say, or just do IMX transfer. And give it the address, the ID, and the receiver, and our key. And we'll print the result in the console. So let's see what that looks like. Yeah, so we get a transfer ID indicating that the transfer is successful. And now if we check our browser, of course the sale's cancelled as well. Or actually, no, we cancelled the sale already. But it's now owned by a different wallet. It's no longer owned by us. So that's exactly what we wanted to do. Now, of course, we cannot only transfer NFTs, we can transfer Ethereum or another token as well. Oh. So let's write a function to do that. Just get the function definition for that. All right, let's create our buffer again. Yeah, let's do the same for token ID. No, the amount is fine. That can be passed as a double. So that should be a float. We'll do the receiver address, which we can copy paste. Okay. Think that should work. Oh yeah, the thing about getting a number or the if I go back to the library, I have these constants stored for various different tokens that you can transfer. Now you can get them from the API as well. I think we actually saw a request for these in the API just now, back when we looked at the marketplace. But they're also stored in here, so maybe I think I'll go over how to actually get these, because I actually had some trouble figuring out how to do that in Python before. So these are just stored as constants in the library itself, and these are exported, so you should be able to access them. Now, if you look up, hang on one second. Yeah, so it's these ones. So when I looked for this previously, I looked for C types get exported variable, because I didn't really know how to do this. Let's see if I can find it quickly, and otherwise I'll just tell you about how I do this. Should just go to Google, by the way. Yeah, whatever. Yeah, they do something like C type, C P, but I think the reason that this doesn't work is that this isn't really a pointer, or at least it's not defined as a pointer, it's defined as an array. I don't think that should matter, because what it should do is just get a pointer to the first character and then read on from there until it hits the null terminator, but I couldn't really get that to work. So the way I'm doing it, we'll just make a function for this, C to string, and then a C variable that we would like to get. And then I just I need to get the address of that variable. Okay, so now I have the address. And then we do C char p dot from address. Hang on, did I import C char? No, I didn't. C char p. And then we can just value decode this to get the actual value. So now if we do something like None. Okay, hang on. Oh, I didn't return it. Yeah, so now we get the actual address that we can use as a string. Of course, if we just do ETH, we just get ETH. Okay, let's see if we can transfer a very small amount of Ethereum. We'll do like 0.0000001, something like that. And we'll do transfer token. Well, we'll just use a string. Or actually, no, yeah, we'll just do ETH. ETH key. Okay, so now if we run this, of course, we're going to get an error message from the server because there's no Ethereum in this wallet. But we can show what that looks like. And show what that looks like. Yeah, so transfer insufficient vault balance error because there's nothing in here. Oh, hang on. You didn't actually see anything I did. Well, that sucks. Hang on. Hey, I'm new to this, okay? So stuff like that happens. Oh god. Yeah, so let's go back a little bit. So we made this transfer token function. It just takes the token ID, amount, receiver ID, and it calls the transfer function like this. So we encode the transfer amount. The amount needs to be a double, receiver address, and the key. And we just decode the result again and return that. And so in order to actually get the variables from the C library, what we do is we just get the address of the variable. So we'll pass something like, we'll do something like like this. Oh, we need to print this. There we go. Yeah, so we just get the address of the variable and then convert that into a character pointer and convert that back into a value, and then we decode that into a Python string. So that's the way I found that actually works. I don't know if there's an easier way to do it, but at least this is the way that I use, and I know that works. So if we try to transfer a very small amount of Ethereum now out of our wallet into this wallet, we get an error message which says that we don't have enough Ethereum in our wallet, which is true. So I'm going to put the stream back in wait for a little bit and transfer a very small amount of Ethereum and then transfer that back. So I'll be right back. All right. So I now have a very small amount of Ethereum in this wallet, and we're going to see if we can transfer that back into the other wallet using the library. So everything stays exactly the same. We should just be able to run this again. And this time it should actually work. And there we go. No errors this time. We get a transfer ID indicating a successful transfer. So now if we check back and we reload this, yeah, it's gone. Now it takes a little bit for the for Immutascan to actually. Oh no, did it? Yeah, it already registered. Wow. Normally it takes a little bit before before the transaction actually shows up in Immutascan, but this time it went really fast. Yeah. Nice. Okay, so I think we have a few functions left. So getting transaction fees associated with a specific NFT and buying. I think I'll just do I'll do one of the two. I'll leave buying for the next time. So let's create another function for that. So let me just get the definition from the library itself. Okay, so this takes a token address and an ID. And it also takes a curl instance, which can just be null, so we can just ignore that. Leave that out. So these are the only two things we need. And this one actually just returns an integer. So we don't need to bother with a string buffer or any of that. Let's call this NFT address like it's called everywhere else. And we'll copy these. We're not actually interacting with the wallet here, so we don't need a private key. There we go, and we can just return that immediately. Right, I think that should work. Let's see. We'll just do token trade fee, address, the ID. And let's see what we get. Oh, error. I did something wrong. Let's see what I did. Oh, maybe I should actually, because it's expecting a third argument probably because of the curl function. Yeah, that's what happened. That's what's going on. Yeah, so this returns 8, which makes sense because there's a 5% royalty fee on Gods Unchained cards. So it's 5% plus 2% for the protocol fee and then 1% market. So which brings it up to 8. So this is mostly, I mean, you're probably not, maybe you're not really going to use this, or well, actually no, you will. If you're setting up a market, you need to know how much fee is going to be added, so you can call this function for that. Other than that, it's used by the function that actually buys cards to check for the fee as well. But that's really all the ways that it's used. Okay, I think I'm going to leave the buying for another time. And then we'll probably also immediately continue to actually building some sort of a... Actually, I'm not sure if we're going to be testing the buying function immediately, because that would mean I would actually have to buy something, which isn't too big of a deal because I can just pick up something that's really cheap. But maybe we'll wait with doing that until I have things set up a little bit more, so that I can actually show like a more realistic buy where you don't actually have to look up a trade using the API and everything manually, but where it actually happens automatically. So maybe we'll just set up the buying function and then move on to how we're going to handle private key storage. So how we're going to encrypt that, store it on disk in a way that's mostly, that should be safe. And then we'll continue with making a very basic trading application for Gods Unchained cards, and then we'll actually demo the buying function as well. But yeah, this is probably going to be the end. This will be the end of the stream today. So see you later.